Okay, so in this video I want to demonstrate pointer variables, and to do that I'm going to start out with some really simple code. So looking at this code, I've got my library and includes right here. I've declared three simple integer variables, num1, num2, and num3 here. I need to give them values, and then I'm printing them out to the screen. So if I run this, oops. There we go. So if I run this, you can see that yes, num1 is 5, num2 is 7, num3 is 9. And if we were to visualize that in memory, somewhere in memory, when we declared these variables, so at the declaration phase, oops, not num3. Okay, so somewhere in memory, num1 was made, num2 was made, and num3 was made. So when we declare them here, the memory spaces are made, but they don't have any values yet. So in this part where we initialize the values, that's when we give them actual values. And so num1 is storing a 5, num2 is storing a 7, and num3 is storing a 9. So we know the name of the variable, and we know its value, and we know it's stored in memory, but we don't know exactly where it's stored in memory. So if we want to know where it's stored in memory, we can use the reference operator to give us the address of these variables. So let's take a look at that. So I'm going to add to my cout statement, and I'm going to say the address of num1 is, and then I need the variable itself, which is num1. I'm going to repeat this for all three, and again, it's very important to remember to actually go in and change the values that you meant to change. Otherwise, cut and paste can be a bad thing. So address of num1, num1, num2, num2, num3, num3. Okay, so but I want it to give me the address of num1 instead. So to do that, I have to add in the ampersand, which is in this case the reference operator, and we can translate that to say when we see ampersand num1, we can think of that as address of num1. So let's print this out. Okay, so as you can see, I have my three nums, and now I have their addresses, which are hexadecimal values. So we've got a combination of letters and numbers because it's hexadecimal. So those are the locations in computer memory where these variables were stored. And one thing that I'll show you here is that every time we run the program, the variables are going to be stored in a different place in memory because your computer is always using and releasing memory, and it's just using new spaces every time. So these are stored right now in 0054F830. when I stop the program, that memory will be released, and when I run the program again, now they're stored in a new place in memory. So they're now stored in 001 DFC6C, so an entirely new location. So if we were to draw this visually, we had our three variables in memory. So num1, num2, and num3, and we had their values, 5, 7, and 9. We also now know their memory locations. So num1 is stored in 001 DFC6C. num2 is stored in 001 DFC60, and num2 is in 001 DFC54. So this is the memory address. That's the variable name. Wow, my writing's getting crazy. And that's the actual value that's stored in that location. Okay, so now we know three things about each variable. We know the value, the name, and the memory address. Okay, so now that we have that concept of variables are stored in addresses in memory, let's look at a pointer variable. So I could make a pointer variable, and a pointer variable excuse me, a pointer variable stores an address location. So it stores a memory address location of another variable. But the pointer variable itself is going to get the type of whatever variable whose address it stores. So because I have integer variables, I'm going to make an integer pointer. And when I make a pointer, I indicate that with a star. So a star in front of the name. So I'm going to call this num pointer. Okay, so I now have this pointer variable called num pointer variable. And I can use that pointer variable to store the address of one of these other variables. So I'm going to say num pointer, and notice that's just the name with no star. Num pointer equals the address of num1. So ampersand num1, meaning the address of num1. Okay, so now the address of num1 is stored in num pointer, and instead of couting address of num1 here, I could cout num pointer. So I'm going to run that and show you what that looks like. Okay, so I still have the address of num1, but now I'm using the pointer to print it out. And you might think, okay, well, how do you know that's the right value? So let's print out both num pointer and on the same line the address of num1, just to make sure that they're the same. Okay, so we have 043F7B8, 043F7B8. So num pointer is holding the address of num1. And if we were to sketch that, visualize that in memory, remember somewhere in memory is good old num1 with a value of 5 and an address this time around of 0043 F7B8. Now if we were to draw the pointer variable in memory, again the pointer variable has its name, and its name is num pointer. And I don't know the address of num pointer because I didn't print that out, but the value in num pointer is actually the address of num1. So in num pointer is 0043 F7B8. So that address is stored in num pointer, and num pointer would have its own address, but I didn't ask for that to be printed out, so I don't know what that is. So num pointer is holding the address of num1. Okay, and we can use num pointer like we did here to print out the address of num1. We can also use num pointer to print out the value in num1 itself. So the pointer has this this ability to reference the value in the other variable, and it does that using the dereference operator. So because the num pointer, if we just said num pointer, that would just give us the address here, but we actually want the value in that address. So we use the dereference operator, which is the star, and that we interpret as get the value stored in this address. Okay, so when I run this, num1 will still be 5. And you can see num1 is still 5, but instead of printing it out using num1, I printed it out by using the dereference operator, this star, saying give me the value that that address contains. And if you're curious, we could also print out the pointer address. Remember, we can use the address operator, or the reference operator, which says give me the address of this variable. The variable is num pointer. So let's put some endls here. Okay, so let's see that. So you can see num1 values 5 is stored in this address. The pointer is stored in yet a different address. So again, if we sketch this out, we've got num1 with a value of 5 stored in this time in the address 0, 0, 4B F C 8C, and then we have our num pointer variable, And remember, num pointer is holding this address, so we're going to have 0, 0, 4, BFC8C is the value that num pointer is actually holding. The address of the pointer is there. That's where this pointer is in memory. So the pointer itself is being stored in memory at 004BFC68. Okay, so remember, this is the value in the variable, and this is the value in the pointer variable. It just so happens that the value in the pointer variable is the address of num1. And then the pointer variable has its own address because it is stored somewhere in memory too. Okay. The other thing we can do with this pointer variable is we had used the pointer variable to print out num1 and to print out the address of num1. I could then change where that pointer variable is pointing to. So if I say num pointer equals ampersand num2, now I've changed that pointer variable to point to num2. And now I could put the same line here, star num pointer, only now num pointer is pointing to num2, so it's still going to print out the value of num2. So we still have the 7 is still printed out because the pointer is now pointing to num2, not num1 anymore. Okay. I could also use that pointer to change the value of num2 before I print it out. So if I said star num pointer equals, that means the value in the address that that pointer is holding will now get a new value. So I could enter anything. I'm going to put 27. So now you can see num2 is 27. And I still printed it out using num pointer. So let me change that back to num2 so that you really believe me that num2 had its value changed by the pointer. And there you see it, 27. So what's happening there is we have num1 in memory, we have num2, and they started out at 5 and 7. We also had somewhere in memory this num pointer, okay, so this address they all start with 0039, so I'm just going to write the last 4 digits of this address. So this address is F778. Okay, but you know it really has 0039 in front. And this one is F76C. So at this line here, we set num pointer to contain the address of num1. Okay, so it had FF78. we said that num pointer 1 was pointing to num1, and we used it to display the value and the address of num1. But then, down on this line, we changed this value and said, okay, it's not going to be this anymore. Now I'm going to get it to point to num2, and we change this value to F76C. So now it points here to num2, and it no longer points to num1. Okay, so now it's pointing to num2. When we get to this line where we say star num pointer is 27, that says the value in the address of the pointer where the pointer, the value in the address that the pointer contains. So it means go to the pointer, get this address, go to this address, get this value, and change it to be 27. So this becomes, that's not a 27, this becomes 27. And the new value of num2 is 27. Okay, that's looking a little messy, but hopefully you get the idea. So whenever we see the star num pointer, it means the value in the address that the pointer is holding will be equal to 27. And when you're thinking about that, I'm going to clear this. When you're thinking about that, remember it is the thing on the left which actually gets its value from whatever is on the right. So 27 is on the right. On the left is the value in the address that num pointer points to, which in this case is num2. This would be equivalent to saying num2 equals 27. Okay, because that's where that is pointing to. But if we were to say something like star num pointer equals num3, that does not set the pointer to point to num3. What that says is the value in wherever the num pointer is currently pointing, which we know is num2, should now be num3. That will set num2 equal to num3. So this line right here is the same as saying num2 equals num3, because we know that this pointer right now is pointing to num2 still. Okay, so if we did this and printed out num2 and num3, num2 will no longer be 27, it'll now be whatever num3 is. So let's look at that. Run this. And you can see that num2 is actually 9 because it's now the same as num3. Okay? So you have to be very careful to know where your pointer is pointing, and remember that whatever's on the left is getting its value from whatever's on the right. And we could also do the opposite and say that I'll leave that line in, so num2 will be equal to the 9 of num3, but then I'm going to change num3 and say num3 will be equal to the value where the pointer is pointing. Actually, let me take that line out so that we don't have confusion. So num3 is going to be equal to the value wherever the pointer is pointing, plus, I could add some values, so let me say 25. So the pointer is pointing right now to num2 still, and then we set num2 to 27. So num3 should become equal to 27 plus 25. So let's look at that. And it does. We've got 27, and then 27 plus 25 is 52. Okay, so the pointer, when we make the pointer, we can now use it to indirectly access other variables by storing their memory address in the pointer and then using the pointer to either print out that address or print out the value.